Hello everyone. Today I thought we'll look at a puzzle. So we'll just jump straight into it. Here we have a chocolate bar. And Afzal, Anoop, and Aman are enjoying this chocolate bar. Afzal and Anoop has a lot of demands. So Afzal wants half of it. And Anoop wants a third of the chocolate. Exactly. Aman is chill. He's okay with whatever is left. So Afzal says he'll make two parts like this. He'll take one part and Anoop do the rest. But Anoop is now confused. How will he take one third of the chocolate? It's already half now. Now what? He says, no, this won't work. He'll split this into three equal parts, like this. But now Afzal is confused. Well, Anoop just took one third of it away, but now there's two of them remaining, and if he takes one, it's not half. It's slightly less than half, and if he takes two, it's still not half. Now what? So this is the puzzle basically. There are two central questions to this. How would the children divide, right? So that Afzal and Anoop, very demanding though, but they get exactly what they want. And we have to do something for Aman as well. So we'll have to figure out what is the total chocolate taken by Afzal and Anoop together. So these are the two central questions. We look at this puzzle from the perspective of presenting it in class. How do we do that? Now, this is obviously related to fractions, and what we'll try to do is we'll try to build up an understanding of fractions based on the answers they give. So here we'll present the problem and we'll make sure the children understand the problem, and we'll give enough time for them to present their solutions. Now what? They'll give crazy ideas, but what do I do with them? Just saying that it's not correct or incorrect and this is the correct way, it won't make an impact because they're still fixated on their answer. Because they would have had a lot of thought process putting that across, and just saying that it might not work might not cut it. So what do we do in this case? So one most important thing regarding this exercise is to have something to make something that is easily verifiable. So whatever children say, it should be easily verifiable whether it's correct or not, and they see it, right? So this is also a very good opportunity to address misconceptions. But at this point, I would not call it misconception. Rather, they are like conjectures that the children are making towards trying to build up their understanding, right? So now, for this easily verifiable thing, what we need is a solution structure that is very obvious and intuitive. So, and whatever they come up with, we'll compare it with this solution structure. So now we'll see what these terms mean, okay, or rather what the examples are. Okay, so now this is kind of the solution structure, which should be very obvious. So I'll tell you what that means. So here, this is the whole chocolate bar that Aman, Anoop, and Afzal wants to eat. Okay, so now Afzal wants half of the chocolate. So I've given a piece like this. How do I construct such a piece? In Mathigon, it's very simple. So basically, we'll use Mathigon to make this verifiable business happen. So I'll split this in half, okay, and this is exactly half of it. No doubt, right? No confusion. Yeah. So now this is 1/3 chocolate bar for Anoop, right? So this is what Anoop wants in the end, no matter what we do. So let's split this into three parts. Okay, and this is 1/3 of it. Right. So what is this? This is basically the chocolate eaten by Afzal and Anoop. So here, this is also made by just combining the two pieces, right? So now, this is the whole bar, no matter what strategy we use, right? Afzal should have this in the end. Let's say I split this into million pieces, and I give a lot of pieces to Afzal and some pieces to Anup. Now I'll put those pieces together, and if I compare it with this, it should exactly the length should exactly match. So now this is a very easy way to verify, right? So now we have like a how it should look like. There is no confusion here. Okay, so now we look at some of the strategies the children might say for these two questions. So for the first one is like, how would the children divide? So I've given like the children's method. Okay, so make a half. Okay, so he'll take the whole chocolate, make it into half, and then one half is for Afzal, and the other half I'll split it into three parts, and then one of the parts he'll give it to Anup. So now let's see whether this actually works. For example, I'll split this into half, and now this is for Afzal. So is this the quantity that Afzal should get? Let's compare, right? So we have what Afzal should get here, and yes, so this is correct. This is fairly fine. So this is what Afzal should want. But now let's look at the remaining part of the strategy. So from the remaining part, okay, he'll split this into three, and one piece he will give it to Anup. So now should this be the piece that Anup should get? Let's compare. So we know what Anup should get in the end, right? Oh my God. It's not. There's something wrong. And what about this combined piece, right? This is also not matching. So this should be the combined piece. But now what we got is this. So from this, they've built up a strategy, but they know something is wrong. It's not working out. It's like it should be this answer, but we're not getting that, right? So I'll present another possible answer they might give. This right now for the second one. So how much is eaten by Afzal and Anup? So here, half has for Afzal. 1 by 3 is for Anup. So now I'll just add them together. How do I add them? Okay, fine. I'll say 1 plus 1 is 2 and 2 plus 3 is 5. So it should be 2 by 5. So this whole part should be 2 by 5th of the whole is what the children are saying. So let's verify it. So this is also something very easy to verify. So at the whole chocolate bar here, we know that this should be what Anup and Afzal should have eaten together, because I mean we've put it together ourselves. So now we'll see whether this is 2 by 5. Okay, 2 by 5th is 2 out of 5, and it's not the piece that we want. It's not the number that we want to associate this with. So this also is easily verifiable, right? So through all this, they will see that their conjectures are wrong. But let's discuss a little bit more about this piece. So we want to associate a number to this, right? So what do I mean by how much of the chocolate bar is taken? So here I have an answer to like a numerical answer to these pieces with respect to the whole. Okay, so I know this is like 1. This is the whole chocolate. And this is half, 1 by 2. This is 1 by 3rd. But now what is this? We don't have a number to associate with this. So this is what we mean by how much of the chocolate bar is taken. It's not that I can show you a picture. I mean, that is a way, but is there a number that I can associate this with is the question. Now, what is that number? How can we figure out that number? let's put like another general thing. So I'm given like some shapes. Okay, so I just know. So this is the whole. So I know that this piece is smaller than the whole, but what number would I associate with this? So one main important thing regarding fractions is that the idea of a whole and splitting the whole into equal parts. And whenever I say a number like 3 by 4, what it means is 3 equal parts out of 4 equal parts of the whole, basically, right? So now when I say, okay, what number should I associate this with? For example, is this 3 by 4? So that's my guess, okay? But how do I check? So I've given, so this is the whole, and this is nothing but half of it, and this is 1/3 of it. So I've already made these pieces, right? So now how do I check whether this is 3 by 4? An easy way is I'll put 1 by 4 pieces together. If 3 of these 1 by 4 pieces of the whole, right, 1 by 4th of the whole pieces will actually, like fit this blue piece, then I can say that, oh yeah, this is exactly 3 by 4. So let's figure out whether it is 3 by 4. Okay. So now I put one piece. So this is the second piece. So 2 pieces, it's not fully cutting it. And the third piece looks like it's going to go overshoot it. Yeah, it is not. So it's not 3 by 4. So at this point, we're just blindly, trying to fit the pieces inside, right? For example, is this like half? No. Is it? And yeah, if I take 2 pieces of half, if it'll just like go over it. But interestingly, this is the whole, right? So I can put 1/3, 3 pieces of 1/3 will make this whole. Okay. So now what other piece can I put? Say, let's try 1/3. Oh, okay, interesting. So 1/3 piece actually fit inside this perfectly. Is this the only piece that fits inside this? Can any other piece fit inside? 1 by 4 did not work. 1 by 5, let's try 1 by 5. Nope, this is 3, and if I have more of it, it's just overshooting. So 1 by 5 did not work. What about 1 by 6? Do you think it'll work? Let's try that out. Oh, 1 by 6 is working. What other piece will work here? So I'll show something interesting. So 1 by 12 also works. We'll get to this later. So so many pieces are fitting inside this, right? Okay, fine. Or exactly matching this length. But the first piece was like a blinder. We did not know what piece could fit inside. We were just randomly trying it. What about this piece? What do you think this piece is? We'll just randomly try a few pieces. 1 by 3rd. Nope, it's not working. 1 by 5th. Let's try that. Oh, this is like 3 out of 5 pieces. What other piece could fit? Can you take a guess right now? So 1 by 10 also fits, right? Okay, fine. So I know what this and this is. What about this piece? So basically, we're grabbing something in the dark. We don't know what piece will match, right? We're just trying to randomly see what pieces. So 1 by 7 is not matching. It's slightly overshooting. Since I made the piece, I know what piece will match. So basically, this is 1 by 11. But now we were blindly trying to figure out what piece will fit inside. Okay, so here, this is the chocolate bar taken by Afzal and Anup. So what piece would fit inside this? So let's just try one by one. 1 by 3. Nope, it's not working. Half. Nope, it's not working. 1 by 5. Nope, it's not working. 1 by 6. Ah, so 1 by 6 works. And because 1 by 6 works, I think we already know 1 by 12 will also work. Right. So these pieces will fit inside Afzal and Anoop's. So now can you figure out a way to split or divide the piece? And can you figure out a number to assign to this piece? Yes, it is basically 1, 2, 3, 4, 5. It's basically 5 out of 6. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is basically 10 out of 12. Huh. So this is a way in which we can figure out the number. But this sounds very crazy, no? So we were like blindly trying to figure out what these were. We did not have anything to go with. We did not have any information. Actually, we do. We kind of do have information. We don't have any information about this piece, but we do have information about what this piece is. So here is a question I leave you with. Something that we can address later on or look at deeply later on is this. So now this piece, this specific piece, we don't know anything about this, but this specific piece we know something about. Afzal had a demand. Anoop had a demand. Afzal wanted exactly half. Anoop wanted exactly 1/3, right? So we are actually looking at this. Given this, can I, without randomly, blindly choosing the pieces, can I smartly choose pieces that I know will fit inside this or exactly cover this? Can I know that, oh, just by looking at this, oh, 1 by 6 is going to cover this, or 1 by 12 is going to cover this? So this is a question I leave you with for this video. Thank you all. Have fun. Bye-bye.